Welcome to our video lecture on solvation, solubility, and precipitation reactions. Our objectives for today, we're going to review solutions and solvation, so much vocabulary. We're going to use the table of solubility of common ionic compounds in water to predict if a compound is soluble. This is in your handy-dandy periodic table reference pages, so if you don't already have that out, grab it now. We're also going to use that same table to figure out when we have a precipitate in a double replacement reaction. So first up, lots of vocabulary. So quick review: solution is a homogeneous mixture. Remember, that's a mixture that is the same throughout. And it's a homogeneous mixture in which we have a substance or more. So we can have one or more substances that is dissolved in another substance. The solvent is the substance that dissolves the other thing, and we call that other thing the solute. And then, of course, the solute is the substance that's dissolved. Dissolved in the solvent. Solubility is the ability to dissolve. Good. Some examples of solutions. Salt water is a great solution. Salt is the solute. It's the thing that is dissolved. The solvent is the water. The water is what the salt is dissolved in. Milk has so many solutes. There's lots of fat, unless it's skim milk, but otherwise there's some fat, there's some lactose, that's milk sugar. There's protein, one of the kinds of proteins in milk is called casein. So lots of stuff dissolved in the water. So water is the solvent, and lots of stuff, lots of things are those solutes. Air is also a solution. So in these two examples, we have solids dissolved in liquid. That's a super common solution, but we don't necessarily have to have a solid dissolved in a liquid. We can have gases dissolved in other gases. Air is an example of a solution. We have carbon dioxide and we have oxygen. We might have a little bit of carbon monoxide. We might have some ozone, all kinds of gases that are dissolved in the air. We're going to call nitrogen gas the solvent because the majority of our air here on Earth is actually nitrogen gas. So solvation is the process of dissolving. What happens is this. So here's a salt crystal. Remember that ionic compounds are lattice structures of positively charged cations and negatively charged anions in repeating patterns. So we have negative, positive, negative, positive. What happens is this. The negative guys, those chloride ions in the case of sodium chloride, the positive hydrogen side of the water molecules are attracted to the negative chloride ion. And so the water molecules will build this like little shield around that anion. At the same time, our positive sodium cations, in the case of sodium chloride, these guys are going to be attracted to the negative oxygen sides of water. And again, we end up with this little shield bubble of water molecules around those cations. And as each of these ions is pulled away from the crystal and is surrounded by water molecules, this, my friends, is how we dissolve. How do we know if something's going to dissolve in water? Well, we have this amazing table, the solubility of common ionic compounds in water table. It is between your list of polyatomic ions and the activity series. So how this table works, these ions are going to form compounds that are soluble, unless there's an exception here. So these guys are the guys that will dissolve, except these ones won't actually dissolve. On the bottom of our table, we have things that are insoluble. That means that they won't dissolve, except when they will dissolve. They will dissolve, they won't. They won't dissolve, they will. Good. So how do we use it? Here's sodium chloride. So let's see if we can find sodium chloride. I see chloride is here. So I don't need to worry about sodium. I can find one piece of it. Chloride is here. So chloride will dissolve except if it's bound to silver, lead, or mercury. This is not silver, lead, or mercury, so this is a will dissolve. Let's try another one. What about potassium nitrate? So I see nitrate is here. It looks like nitrates will dissolve always. There are no exceptions. So this one is a will dissolve. How about next up, magnesium iodide? I see iodide is here. So this guy is another will dissolve, except when it's with silver or lead or mercury. This is not silver or lead or mercury, so it is another will dissolve. So these guys I would all describe as soluble because they will dissolve. Let's do one more, and then I'm going to have you do the next 3 in the Ed puzzle. So lead to iodide, will or won't, will or won't. Let's see. So if I go to my table, here's iodine again. There's iodide. So it will dissolve except when it's with silver or lead or mercury. In this instance, we do have iodine with the lead. So this one is actually a won't dissolve. We're going to call this guy insoluble. It will not dissolve. All right, I want you to do 1, 2, 3 in the Nearpod. All right, let's do some quick answers. This is ammonium. Notice ammonium is here. It's one of the, well, it is the only, not one of the only. It is the only positively charged particle on the list. It is always soluble. So this one will dissolve. It is soluble. How about magnesium hydroxide? Magnesium hydroxide. Hydroxide is on the won't side, except if it's with ammonium, the alkali metals, so that's group 1 in our periodic table, calcium, strontium, or barium. Magnesium is not on this list of exceptions. This is a won't dissolve. Magnesium hydroxide is insoluble. One more, let's look at calcium hydroxide. Back to that hydroxide, it won't, except if it's with calcium's on that list of exceptions. So that means that calcium hydroxide actually will dissolve. It is in fact soluble. So now we're going to take this idea and apply it to precipitation reactions. So a precipitate is a solid product formed from dissolved or aqueous is the better vocabulary word, aqueous reactants. So silver nitrate, nitrate's here, it's going to be soluble. This guy is aqueous. It's going to be soluble. Sodium chloride, chloride is here. Sodium's not on my list of exceptions, and so sodium chloride is also aqueous. Sodium nitrate, nitrate again, always soluble. So this one again is aqueous. What about silver chloride? So I go here to chlorine and notice that silver is one of my exceptions. So usually chlorides are soluble except if chloride is with silver. So this guy is going to be insoluble. That means it's not going to dissolve. It cannot be aqueous if it's not dissolved. Instead, it will be solid. This solid product of these two aqueous dissolved solutions, this, my friends, is the precipitate. And that means that this special kind of double replacement reaction is a precipitation reaction. And we call it precipitation reactions because when we mix these guys together in a test tube, we end up with cloudy things forming, and then over time they will settle down to the bottom of the test tube. Just like rain or snowflakes will fall down from the sky, our little precipitates will fall down to the bottom of our test tube. Good? I'm going to have you do this one in the Ed puzzle. figure out which product, we only need to look at the products, which of these products is the precipitate. Remember that the precipitate is the solid, insoluble product of this reaction. So hopefully we looked at chlorine and noticed that chlorine is here. Potassium chloride is not an exception, so this one is going to be aqueous. It will dissolve. What about magnesium hydroxide? I go down here, magnesium hydroxide. Magnesium hydroxide is not one of the exceptions, and so magnesium hydroxide will not be soluble. It is insoluble. It is going to be one of our solid products, which means that magnesium hydroxide is the winner. It is the precipitate in this precipitation reaction. Let's do one more, and then we're going to call this lecture done, my friends. Find the precipitate in this reaction. All right, you might be thinking, wait, trick question. There are no precipitates. You're right, my friends. This is not a precipitation reaction because there is no precipitate. Potassium chloride. Chloride is here. Potassium is not an exception. This will dissolve. Barium nitrate. Nitrate is here. There are no exceptions. Nitrates always dissolve. This guy will also dissolve. Nothing was a solid. There is no precipitate. Trick question to wrap up today's lecture. Good work. We definitely reviewed that vocab on solutions and solvation. We used that table of solubility of common ionic compounds in water to figure out if compounds were soluble or insoluble, and then we identified precipitation reactions. Remember that the precipitate is that solid or insoluble product of two aqueous solutions. Good work.